Hello everyone. Today I'm going to share the presentation related to this scientific award and hope you are able to see my screen. So this is the ScienceFather Cybersecurity International Conference and Cybersecurity and Cryptography Award presentation. Today I'm going to present about enhancing the security in cyber world by detecting the botnets using Ensemble classification based machine learning. By the way, my name is Sathiyandrakumar Srinivasan. I'm a PhD scholar and I'm from the Kalasalinga University. Currently, I'm working as an software engineering department. Uh, so moving to the next slide. Uh, this slide, we are going to talk about uh, the coursework, whatever I have completed, and specifically this is related to the objective for this presentation, what we have described, and we are going to specifically talk about to identify real user from the robot with unusual variation in the number of servers of access to over time using the regression based model. So this is the essential one because we are talking about how the cybersecurity issues is the challenging one. Uh, so hence, the subject is providing more information uh, and how we can resolve these issues in the going forward. So we are talking about ensemble classification, which the threats we are using here. Um, what is the threat in the cybersecurity? So these threats against information security have increased these days. So if you take any scenarios in the uh, any sectors or any domain, so the cybersecurity is the biggest challenge for any organization. For example, if you're seeing the daily awareness that some customer information have been compromised and some customer information have been used for some other purpose kind of thing. So this kind of thing is the challenging one, the cybersecurity area. So this particular objective is meeting to resolve this kind of issues actually. So typically, what is happening? The unusual variations in the number of servers access to over time has increased, and that's the reason among several threats. The emerging one is botnets against cybersecurity. But the new malware compromises the computer, and the botmaster controls the execution by the commands received. Recently, most botnets have replaced Internet Relay Chat. It is called as IRC protocol, which is forming a larger social chat rooms. When a data set contains both linear and non-linear data, ensemble techniques are particularly effective. Ensemble approaches have high prediction accuracy over other approaches, whereby the data in this research work can be handled effectively by the ensemble approach. Moving to the next slide. This is related work have been completed where the models have been used, and there is a certain limitation that we are going to talk about. So ELM, it has a low detection rate, high complexity and uncertainty. The hybrid model, which has the to select features and classify cyber attacks, and it is not simple structure. It is produced a high false positive rates. That is the limitation it has. Deep learning based botnets traffic analyzer model, it is impossible to disseminate botnet malware from social networks. And the final one is system of master learning called as ML model, which has restriction or limitation, which is the domain adoption problem was introduced as lists were not from the same source and were of poor quality of the quality for classification. So the system model perspective, this slide we are talking about a proposed model which emphasize on the command and control channel that is assumed as the bots are with the preliminary communication phase, and applying this model at this stage is advantageous. The proposed classification method in which pre-processing is the initial stage where redundancy is eliminated and data analysis is performed. And the same thing, it is the better one is execution, followed by this process for the detection of botnets at the CNC initial stage, and the proposed bot master connected with the internet and connected through the command and control servers, which directly interacted through the workstation. So this is the architecture for the proposed botnet classification method. Here, the multiple servers have been interacted with different kinds of network traffic and producing the results. And this is the similar architecture for the proposed boot master interaction model. So here, if you see the different kinds of workstation, which is we already talk about the command and control servers are incorporating these things. And this is the feature selection using kernel method, where we are typically using the uh, classification method for the feature selections, which we described on the slide. And this is the continuation of the ensemble classification with the stacking process. So how we have classified and how that method have been used, that we have been described over here. And this is the ensemble classification process, which we are talking about the training data and final detection as an output, how we are deriving from the level one detections, and how various levels we have, and meta classifier, how it is drawing into the final detection that we have explained in this slide. And this is the stacking process algorithm, which using the ensemble classifiers, where we have used this algorithm to detect the malware. And it's a successful one because we are able to see the significant improvement on this one. Um, uh, that means that the result, the accuracy have been improved, and the detection also have been improved. So it is working fine as expected. Under the performance analyst perspective, we have evaluated ELM and SVM and CNN model with classifier algorithm with the stacking process that we have described in this slide. And this is the slide where we have used the description of the feature set. And here we have used PKT kind of various features, and the data type, and we have used the number of features, and we have used the description also over here. And this is the performance metrics we have described. So the performance metrics taken were accuracy, false positive, true positive rate, and the F measure, which is the given below. Here, botnets such as Neris, Arbot, or Virtute, Menti, Sogo are considered. These measures are specified based on the definition given below. The correct prediction of botnet attacks is indicated by TP. Same thing, uh, the standard data have been detected, indicated by TN, and the incorrect classification botnet attack is specified by FP, uh, and the incorrect classification normal data is specified by FN. Okay. So here we have described how the accuracy, sensitivity, and specificity and F measure have been classified. And this is the overall comparison of the accuracy. What's the proposed method difference between um, the existing methods. And the number of packets have been used here are similar. And the same thing here we have elaborated in the GUI perspective, the graphical user interface perspective. And this is also we are using the comparison of the sensitive with the existing method and the proposed method, and we are able to see the significant difference over here. And uh, next, we are seeing that how the differences is illustrated in the graphical representation. So here we are able to see in the slide. And the next slide, we are talking about comparison of the specificity. Here we are talking about how the proposed method is differ from the existing one. And the next slide, we are going to talk about same the specificity perspective in the graph. So this we are able to easily identify how it is different from the proposed method. And other than that, uh, we are going to talk about F measures on this slide. Here we are able to see the difference between the proposed and the existing method, where it is providing the complete information and how it's more, uh, that means accuracy than the previous method which they have used. This is the graphical representation for that similar method where you are able to identify the proposed method, the differentiation from the existing method, how it works. And this is the overall comparison of the existing and proposed methods on these things. So the last column is indicating the proposed method, and we are able to see the significance of the differences between the proposed and existing methods. And this is the overall summary which we are talking about how the uh, several attacks on the internet botnets are considered the key vehicles. And detections of botnet is challenging due to the various botnet protocols and their structures, and the performance of the machine learning architecture is investigating by the fine tuning the hidden layers and the neurons. The performance of the botnet detection is evaluated using publicly available datasets, and experiments showed that ensemble classifier algorithm with the stacking process is better for botnet classification by achieving 94.08 percentage accuracy, and sorry, accuracy, and is 86.5 percentage sensitivity, 85.68 specificity, and 78.24% of F measure. And this is taken to test and evaluate network flows performance and identify the class as a standard and botnet attacked file. Future work concentrating on developing a natural network model direct botnets is underway, and submitted the paper later for related to these objectives, and the related publication have been completed, and this is Scopus index, and it is successfully accepted and published. Yeah, and you may have similar some questions related to this presentation, and if you have any questions, then please reach out me, uh, and I will be happy to answer your questions. And at this moment, I would like to thank you for your time and hearing this presentation, and I hope you have a fantastic evening, and thank you for Science Father for this opportunity. Thank you so much.